Okay, so today, like I said, we are doing reflections. So reflections are another type of transformation. It changes a shape in a certain way. Yesterday we saw it with moving shapes left, right, up, or down. Today we're going to be flipping things over a line, so they're like mirror images of each other. So they'll look slightly different, but we're still going to follow lots of the same processes for graphing, all of that. Okay. So a reflection is a type of rigid transformation that uses a line like a mirror to reflect an image. This mirror line is called the line of reflection. Reflection. Okay. All right. So let's say we have our line of reflection in these two pictures. So our line of reflection is line M for both of these. Okay. If our point is not on the line of reflection, so notice that point P is not on my line of reflection, it's off here to the left. If I were to graph the image of that and I were to reflect it over this line and get P prime, P and P prime should be the exact same distance away from the line of reflection, okay? So if your point is not on the line, which I would say normally it's not on the line, it's not as common for it to be on the line, then you just have to make sure that the image is the same distance away, okay? So this says here, if P is not on line M, then M is the segment bisector, meaning that it's cutting that segment into two equal parts, okay? So P to the line is the same distance as the line to P prime, okay? Now, if the point is on the line of reflection, so notice in the second picture, point P is on the line M, then if you were to reflect that, the point would not be moving, okay? It's no distance away from the line, so you can't make it like an equal distance. It would just stay exactly where it's at, okay? So in that case, point P would just be point P prime. All right. So we're going to go ahead and try this with an example with counting, okay? So we have 2 points. We have point A and we have point A prime, okay? So altogether, that segment is 1, 2, 3, 4, 5, 6 boxes, okay? We said right here that the line of reflection should cut those 2 points exactly in half. It should come directly in the middle of those 2 points. Therefore, if that's a total of 6, okay, A and A prime are 6 boxes away, that means the line of reflection should be 3 boxes away from both points. Okay, so I'm going to do that like this. So if I go 3 that way, or if I were to go 3 this way, okay, where those two meet would be my line of reflection. I'm going to go ahead and do that in a different color. So again, the line of reflection should come directly in the middle of the 2 points. And again, it's directly in the middle because there's 3 on this side, 3 on this side. Okay. Now we're going to put our Algebra 1 thinking caps on here. Whenever we see a vertical line like this, so my next question for B is, what is the equation? Yes, I expect you guys to know how to write equations of lines. You guys spent all of first semester last year doing so, okay? If you don't feel comfortable writing the equation of a line, you don't remember how, whatever the case is, you need to come see me this afternoon. There is no way that you will be able to complete the worksheet successfully without knowing how to graph a line, okay? So if I were to write the equation of this line, since it's a vertical line, anybody know what the equation should look like? Point B at this location, okay? And I want to reflect it over the same line, I want to reflect it over the x equals 1 line, okay? We said that A should be the same distance away from the line of reflection that A prime is. They both should be 3 boxes away on either side, okay? So if I want to figure out where B prime would be, I know it's going to be somewhere over here. It should be the same amount of boxes away from the line of reflection as point B is. So let's figure out how many boxes away point B is. That should be 5 boxes away. So I would do the same thing. Go 5 boxes over on the other side. So again, everything should be like equal distance away. Okay. Who can tell me what the coordinates of B prime are? Okay, awesome. So you should get 6, 5 for that, okay? We're gonna go ahead and do this with more horizontal and vertical lines. So this was a vertical line here, okay? We're gonna do it with both. So for the first box that we see here, we're just gonna come up with some like rules or just generalizations about reflections, okay? So we can either flip for this first part over horizontal lines or vertical lines, okay? So a horizontal line, if we were to flip over that, we would be changing the y value, but the x value would be staying the same. And if we were to flip something over a vertical line, so that's what we did up here, this line going up and down is vertical. The x's were now changing, but the y's stayed the same. Okay, that's why when we looked at like B and B prime, they both had a y value of 5. Those stayed the same. It was the x's that were changing. And we'll count boxes for all of this, so you don't necessarily need to like memorize what changes and stays the same. It's just helpful as you're like going through things to like just remind yourself, okay, should this be changing? Should it not be changing? Just as like a second check, okay? But you don't necessarily need to like memorize that. Okay, so graphing, this all says translations. I need to like redo that. So when we're graphing reflections, we have similar steps to how we graph translations. So we're going to graph the pre-image. So we're going to graph whatever points it gives me, whatever shape it gives me. That's what we're going to start with. I'm going to, in addition to yesterday, graph the line of reflection. You can either do it dashed like I have, or you can just do like a solid color. I would just make sure that you keep it very distinguished from all of the other stuff. You don't want it to all just look like black and white, because it can be really tricky to then like count boxes and make sure it's accurate. Okay, so that's my recommendation. Okay. We're going to use whatever rule it gives me, whatever line to reflect over. We're going to use that, and we're going to find the coordinates for the image, and then we're going to graph it. Okay. All right, so we are given triangle DEF. So we have these 3 coordinates. I'm going to go ahead and plot those. Okay, so go ahead and plot those. All right, this is why it's helpful to have a note packet for this unit, because we're doing a lot of plotting. Okay. And then it tells me that I want to reflect this triangle over the line y equals 2. Gives you the line right here. So I'm going to go ahead and draw a line. If it's helpful to you, in this little box that we have up here with horizontal and vertical lines, just as a reminder, if you see something vertical like what we saw in this original example, your equation will be x equals something. It's going to be a number, okay, but it'll be x equals something. If you have a horizontal line, it's going to be y equals a number. And I'll put the number symbol just so we know it's like that, okay? So since this is y equals something, I know it's going to be a horizontal line. And specifically, it should be a horizontal line, so a line going left to right, going through y equals 2. So y equals 2 is right here. You go on your y-axis up to 2, make a line. Okay. Once you have the picture and the line, it just becomes a matter of counting boxes like what we did in that original problem. Every point D, E, and F should be the same distance away to the line of reflection as D prime, E prime, and F prime. Okay, so I'm going to count boxes to see how far away should everything be. Okay, so point E, I'm going to start there. That is 1, 2 boxes away from my line of reflection. D prime, or I keep saying that, I said that last hour too. E prime should also be 2 boxes away from my line of reflection. E prime. Okay. F prime is 1 box away from my line of reflection. F prime should also be 1 box away. Make sure when you're counting your boxes, you're going on either side of the line of reflection. So notice that E started at the top. When I flip it over the line, it now goes to the bottom. F started below the line of reflection, so when I flip it, it goes to the top. Okay, so just make sure that it is flipping. It should be on either side. Okay. What about point D? What happens to point D? Okay. So again, D would say D prime since it's on the line of reflection. Okay. I'm going to connect those 3. Like that looked weird for a second. There we go. All right. So sometimes it will overlap like that. It's not always like perfectly one thing's on top, one thing's on bottom. Okay, it could overlap like this, and that's fine. Okay, we're going to try doing it with the same triangle, but now flipping it over a vertical line. So we're going to plot the same 3 points. So we have D at 0, 2, same 3. Okay. Shape looks a little weird, sorry. And then I'm going to go ahead and draw my line of x equals 4. So again, this is a vertical line. Okay, x equals a number is vertical. So I'm going to go to my x-axis. I'm going to look for 4. 2, 3, 4. You can always make a dot there if you want to, okay? And then it should be a line going through that point that is vertical. Okay. And again, we're going to count some boxes. Instead of counting up and down now, we're going to be counting left to right. Same idea, okay? So I'm going to start with point F. So F is 1 box away. Go the other direction, 1 box away. That's F prime. E is 1, 2, 3 boxes away from the line of reflection. E prime should be also 3 boxes away. And point D is 1, 2, 3, 4 boxes away from the line of reflection. So 1, 2, 3, 4 on the other side. And like that. Okay. Okay, so the ones on this page are very similar. We're still going to count some boxes, but instead of having like reflected over y equals 2, reflected over x equals 1, whatever the equation is, it's just going to tell us to reflect it over an axis. Okay, so either the x-axis or the y-axis, but it's going to be the same process. So we're going to do all of the x-axis. I'm probably not going to do the y-axis. We'll just kind of talk through it because they are, again, same as what we just did, very similar. Okay, so we have 3 points. We have L, M, and N. So I'm going to plot those. Oh. Okay, those three. And it tells me that I want to reflect this over the x-axis. Be very careful. Having an equation that is x equals something is different than flipping it over the x-axis. Okay, the x-axis is the axis that runs left to right. Okay, so we're going to be flipping it over this line right here. Okay, so a lot of algebra, things that we have to remember about graphs, okay, for this day of notes here. All right, from here I'm going to go ahead and again count boxes. So for n, I have to go one away, n prime. Point M is 2 boxes away from my line of reflection. And L is 1, 2, 3 boxes away. If you don't like all the bubbles and stuff on your paper, you can obviously count boxes without doing that. I just do it so it's visual for you guys. But if you prefer not to have that many marks and stuff on your paper, you can probably count without it, okay? But it's up to you. All right, so we have that. All right. Anybody know what the coordinates of L prime are? So when we see something flipped over the x-axis like this, what's happening, and I'm going to write a little rule here for you guys. So it's kind of how we wrote them yesterday. We started with x, y, and then it changes to something, okay? So what's happening is the x's are staying the same and the y's are changing, and specifically they're changing by flipping signs. The way that we write this is we write it as looks like a negative y, okay? When you see a negative symbol like this, all it means is you use the opposite sign, okay? Or you change the sign, it's negative becomes positive, positive becomes negative, okay? Now, if you maybe had to make your best guess as to what the rule would be for flipping over the y-axis, so the y-axis now is the one going up and down, what do you predict might happen based on what we know for the rule for the other? Over the y-axis, the opposite happens. So the x changes. The x would become either negative or positive depending on what it starts as, but the y would stay the same. Okay, awesome. And I'm not, again, going to do that. It's counting boxes. It's the exact same thing, but this is a nice little set of shortcuts if you want to use those. And I would just recommend, depending on what the question is asking, I would probably solve it different ways. So if the question just literally said, graph the image, I would just stick to counting boxes. Let's say it doesn't give you the graph and it just says, here are 3 coordinates, write what the new points would be if you were to flip it, then I would probably use the rule, okay? But if it wants you to graph anyway, I probably would just do it with the graph. I wouldn't even worry about the rule. But just kind of depends. Okay. All right, last ones, we're almost there. Okay, so we have 2 other lines that we can reflect over. We have the line y equals x and y equals negative x. So we learned these, or you guys learned these, last year in Algebra 1. So if I were to graph the line y equals x, I'm going to just graph both of these first as a review, okay? So if I were to graph the line y equals x on this first graph, I know that I need to start at the origin, okay? And what would my slope be? Since our slope is 1, I would have to go up 1 over 1, up 1 over 1, that whole jazz, okay? So I'd be going up 1 over 1, up 1 over 1. I'm going to do mine as a dashed line, okay? Instead of making points. Okay? Y equals negative x should be very similar. So you're still going to start at the origin, but instead of your line going up 1 over 1, it should be now going down 1 over 1. And that's because, again, it's a negative x, so your slope's a negative 1. Okay? So down 1. Look something like this. Okay. So we have our 2 lines, okay? Now, when you reflect over the line y equals x, if I were to start with the point x comma y, it would change by simply flip-flopping the x and the y. So the y goes in the x spot, the x goes in the y spot. So they literally just switch. Okay. Again, if we start with xy and we flip it over the line y equals negative x, what happens is they not only switch places, but they also become the opposites. So y becomes opposite, x becomes opposite, and they switch places. So there's two things going on. Okay. So I'm going to go ahead and try these. And really, you need these rules for these lines because you can't just count boxes because the lines are not perfectly vertical or horizontal. Since they're on a diag, you can't count boxes away from it. So you have to know these rules, which, yes, your test is still going to be open note. Okay, so they'll be here for you to use. And honestly, even if it wasn't open note, when we're face-to-face, I always provide these rules anyway. So you guys should be fine. Okay. All right, so we have 2 points on a segment, A and B. So I'm going to plot those. A is at 3, 2. B is at 4, 1. Okay. And I'm going to flip this over the line y equals x. So my rule for that is for the x and the y for them to switch places, okay? So if my A starts off as 3, 2, when I have them switch places, I now have 2, 3. And for B, it starts off as 4, 1. When they switch places, I now have 1, 4. So they're literally just flip-flopping. So I'm going to go ahead and plot that. A prime and B prime. For this one, I feel like sometimes people just make their best guess. And sometimes that works out, sometimes it doesn't. So I would just make sure, use the rules. They're there. They're super easy to use. I know sometimes people can visualize it and make their best guess, and it's right, but not always, so just be careful. Okay. All right, and then the last one of the day. So for these, they should switch places, and they should become the opposite symbol. So I still have the same 2 points that I'm starting with. A and B. But now instead of flipping, from the upper left to the bottom right to the upper left, we're going to be flipping from here to here. Okay. So they should switch places and become the opposites. So point A starts off as 3, 2. When they switch places, I now have 2, 3. Since they're both positive, they should both now become negative. So this would be -2, -3. They switch places and they become the opposite signs. For B, same thing. It starts off as 4, 1. They're going to switch places and become the opposites. So they switched and became opposites. So we'll plot those. A prime and B prime. You should get that. And I would just make sure as you're graphing these, just make sure they make sense. Like if you were to flip it over this line, you shouldn't end up with like something over here. Okay, that would make literally 0 sense. They should be mirror images of each other. Okay, so just make sure you're looking at it to, make sure that it makes sense. Okay. Alrighty. Any questions on what we did today? We're gonna do